Hi everyone, so this is our lecture overview on uncertainty in data. So important vocabulary for you. This is something that is used a lot in data collection. Doesn't have to be chemistry, but just data collection in general. We have accuracy and precision. These words sometimes are used interchangeably, incorrectly, because some people think that if you're precise, you're accurate and vice versa, but they're actually very different. So accuracy is how close a measured value is to an accepted value, and precision is how close to a series of measurements are to one another. So here is like a very important visual that is used all the time when trying to compare these two words. And so you're thinking about something like archery, or even, at a gun range when people are practicing their shooting, right? So this is a bunch of targets. So if we take a look at the first one, it says that the first one is precise but not accurate. So again, precision means that you're all, measuring around the same area. So that's what this one is showing us, is that they're all in the same area. They're precise, but they're not here at the target, right? You want to be at the target. The second one is accurate but not precise. The reason that is because they're closer to the target, right? They're not all in the same spot, but they are closer to the target, so they're more accurate. The third one is neither precise nor accurate because their shots are all over the place, right? So, this might be more characteristic of a beginner, right? They're all over the place. And then the last one is precise and accurate because all of their shots are in the middle. So this would be someone who's a really good marksman, right? Or somebody who's really good at archery. They can hit that bullseye multiple times in the same area. So this is, again, a very good analogy for you if you need a visual. So a couple of important vocabularies as we go through our topic of chemistry. We have error and percent error. And again, this doesn't have to be in chemistry. It can be in any other sciences that has to do with data collection. So the first one is error. That's the difference between an experimental value and an accepted value. And here's the equation right here. Pretty much what that means is you're just subtracting them. And then percent error is just expressing that error as a percentage, right? If you're a little rusty on your math, these bars right here are called absolute values. Hopefully that's what you said. Absolute values, meaning that even if the error is negative, right, we will turn it into a positive value and then divide it by the accepted value, multiply it by 100 to turn it into a percentage. The accepted value, these are usually given to you, right? Accepted value just means that this is what we as scientists, or we as, even physicists or chemists or biologists, this is what we know as the number for this particular element, for example, right? So this is what we know of at that moment. So here's an example. This is from your textbook, right? So this is looks like a lab that was done, right? And there are different students that are, looks like recording different densities, and then they are given an error. So how close were they to the given density, which is this one right here, right? So there's 3 different trials, and the book was nice enough to tell you that A, which is these right here, are the most precise. So most precise meaning they're the ones that are very close to each other. So if you take a look at it, 1.70, 1.69, and 1.71, so very close to each other. So student C was very good at measuring precisely, right? And then it says that this one, so student A's average is the most accurate, meaning it's the closest to the 1.5, which is the given density, right? So how do we turn those into percent errors, right? So this is what we're going to practice. I just want to write this out again, but the accepted value was 1.59 grams per centimeter cubed, right? And then the errors, and I'm just looking at the first student here, this one right here, right? So the errors were negative 0.05 grams 0.01. So this is 3 different errors that we're going to turn into percent errors. Okay, so hopefully you remember the equation. If not, then here it is again. We're taking a look at this one right here, percent error. So let's do the first one. Right, so percent error. So we're going to take our value. So here's our absolute value bar. So negative 0.05 over your accepted value, grams per, and that was bad example there. You want to add your units. Units are very important, especially in chemistry, times 100. So again, you can plug this into your calculator, probably the easiest way to do that. But again, this negative goes away, so you're just pretty much doing 0.05 divided by 1.59. Right, so if, again, you can plug that into your calculator. I'm going to do the same, 0.05 divided by 1.59, and you should get 0.0314. And then you have to multiply that by 100. Right, so you're going to multiply that by 100, which just means you have to move your decimal over. Your answer should be 3.14% for the first error. Right, so why don't you guys pause and do these two right here on your own. Pretty easy, you're just dividing and multiplying by 100. So pause right now, do the others on your own, and then come back and I'm going to show the answer. Okay, so let's do the other ones. Hopefully you tried it out on your own. So again, absolute value, I'm going to try to make them all fit here, otherwise I'm going to have to erase the other one. Absolute value divided by our accepted value, sorry for the messy writing there, times 100. Right, so hopefully your final answer was 0.63%. And yes, you can have decimals for percentages. Again, percent just means you multiply by 100, so you have to move the decimal over. And then the last one might be a little bit tiny because I'm just trying to fit it, but let's see how it goes. Units are important. Make sure you add them. Accepted value with units times 100. And hopefully you got 1.26%. And that's it. Pretty straightforward. We're going to do an activity with this to give you more practice, but that's pretty much it. So it's just telling you, you know, how much error is in what you did. So like, for example, right, a lot of measurements in chemistry specifically, we use a lot of like beakers and graduated cylinders, thermometers even, right? But they're not perfect. Sometimes it's manufacturing, sometimes it's, I don't know, just the way you read the numbers, right? But there is an accepted value that we know about. So the errors can happen because of different reasons. So we need to give our readers, our the public, if you're in sciences, you need to give them a percent error so that they know that this is not the exact, but this is how close it is to the accepted value. That's why we do this. Right? Okay, so we're gonna do more practice with this, and we'll hopefully get the hang of it soon.